Hi guys, my name is Parag and welcome back in my new video. Guys, in this video I'm going to explain you how you can solve step-by-step numerical based upon the 2-hinge arch. So this is one of the very important video for all of you because this video will split in 3 parts where you can able to understand how you can calculate horizontal thrust, right? Position and magnitude of positive and negative bending moment, then normal thrust and radial shear at certain distances, also normal thrust and radial shear at the ground, and normal thrust and radial shear particular distance from the right side. So this numerical consists of different type of questions, right? And in your examinations you may find this kind of questions for around 50 to 20 marks, right? So this is very important numerical for all of you, so you need to watch this video till the end. And if you want the notes for this video, so you can find these notes for this video on www.civilnotes.com. Okay, and you can find lots of interesting civil engineering notes, okay, for different kind of subjects, gate examination and SSC examinations on this website, right? So let's get started. So first of all, let's understand a numerical. A 2-hinge parabolic arch of span 32 meters. So we have a parabolic arch with a span of 32-meter length, right? With a central rise of 8 meter, carries a UDL of 50 kilonewton per meter. So see, we have in most of the scenario you won't get the diagram, okay? So you will only get the theoretical portion. So you need to understand this theoretical portion properly. So this numerical says that a 2-hinge parabolic arch of span 32 meters. So you can see this diagram. Okay, so 2 hinge. So this is a hinge number 1. This is hinge number 2. So these are the 2 hinges. Okay, having the distance of how much? 32 meter. So 32 meter is a length between the two supports, right? So this is a span length we can say, right? With a central rise of 8 meter, what does it means? It means that you are having the height of small h as a 8 meter, right? So this is the central rise you have right now, okay? Carries a UDL of 50 kilonewton per meter, and you can see that they also mention the UDL, uniformly distributed load, of 50 kilonewton per meter is mentioned, but still after that it is mentioned over the left half span. So where it is provided, where it is applied, on the left half span. So you can see it is applied on this portion, okay, left half span. In most of the scenario, the questioner in the examinations, they might provide you the diagram, or if they not provide the diagram, they might change the sentence such as from 2 meter from the left span, 5 meter from the right span, okay, 10 meter from the right span. Such type of conditions they might create, right? So you need to understand the theoretical question and draw the diagram like this. So see what we have drawn here. We have considered 2 hinge support. Okay, the distance between these 2 hinge support is 32 meter. Then we draw the parabolic arch like this, right? And the height which is mentioned is 8 meter, right? And also we have provided the UDL of uniformly distributed load of 50 kilonewton per meter over the left span. So this is the left and this is the right span. Okay, so let me remove everything right now from here. So we can easily start working for the rest of the things. Right. Now let's understand one important thing. When you are solving this kind of numerical, so the hinge support, when we are considering the hinge support, always have two type of the reactions. The first one is the vertical reaction and another one is the horizontal reaction. So in this scenario you can see we have provided the vertical reactions and the horizontal reactions. Also at the B point we have the vertical and horizontal reactions. Okay, so there is a two type of reactions we have drawn over here, right? Now let's understand the calculation of horizontal thrust in this numerical, in this video, sorry. So first of all, to calculate the horizontal thrust, let's calculate the vertical reactions, okay, using the condition of equilibrium. So condition of equilibrium means what? So first of all, whatever the diagram you have drawn over here, just prepare this diagram in the beam format. So you can see there is a beam we have drawn over here. Okay, so this beam is having the support of VA and VB at the both side, and the beam is having length of 32 meter, right? So the half span of this beam is consists the uniformly distributed load, okay, UDL. So this UDL which we have drawn over here, so what we have done, we just minimize the height, we just neglect the height right now, and we have drawn one beam over here. So we can able to calculate the vertical reactions easily, right? So see, first of all, we are using the condition of equilibrium. So in that case, condition of equilibrium means all the forces along the y directions, the forces going from bottom to top are in a positive sign, and top to bottom are in a negative sign, right? So VA is moving from the bottom to top, okay, VB also moving from bottom to top, okay, minus, so VA plus VB minus this uniformly distributed load we need to convert in the point load. So UDL multiply by the length. So that point load convert the UDL convert into the point load. So VA plus VB minus 50 into 16. Okay, 16 is why? Because it is on a half span. The UDL applied on a half span, right? So 32 divided by 2 means 16 meter. So you can see we have 16 meter over here. So VA plus VB minus 800, 50 multiplied by 16. So VA plus VB equals to 800. So now we have one equation which defines the relation between two vertical reactions. Correct? Now let's provide one moment at any support. Okay, so I am giving a summation of moment at A support over here. So I am providing one moment at support A. So what will happen? Just consider the clockwise and positive and anti-clockwise negative sign conventions, right? So VB will act as a anti, oh my god, my bad. Okay, so VB will act as a anti-clockwise. Okay, so what will happen is minus of VB into 32 plus, now we have the point load 15 multiplied by 16, right? So 15 multiplied by 16 multiplied by 16 divided by 2, which is 8. So whenever we are doing, like, see, it's very simple. I'll just give the calculation properly. So we just multiplied the force, okay, with the distance, that is called movement, right? So minus VB because it is moving anti-clockwise direction along the support A. So minus VB into 32 plus 50 into 16. Why? Because we have converted into point load, but now this become the load, but it will act over here. So this distance is become 16 divided by 2, which is 8 meter. Okay, so that's why it is multiplied with the 8. Correct? So what will happen is, now we are calculating the value of VB. So minus VB into 32 plus 16 into 50 multiplied by 8. So we now got the value of VB as a 200 kilonewton. Understood? Now what happen is, we need to put the value of VB in the following equation, such as in this equation we need to put the value of VB. So how we'll do that one? So we need to just put the value of VB in this equation. So VA plus VB equals to 800. So VA plus VB's value is 200. So VA plus 200 equals to 800. So VA equals to 600. Now see, it is very simple. We calculate the value of VB and we calculate the value of VA. That's very easy. Correct? Now let's jump into the next equation to calculate, okay, few of the things, such as to calculate the horizontal thrust, because till date we need to calculate the horizontal thrust in this equation, in this video, right? So the second step to calculate the horizontal thrust is to use the equation of parabolic arch, right, in the term of x. So this is the equation of the parabolic arch. Y equals to 4 into h into x in bracket L minus of x divided by L square. So here you can see the h defines the height. Okay, L define the span length. right? Understood? So what we have to do is y equals to 4 into what is the value of h over here? So see, we have the value of h as a 8 meter. Okay, so let's put the value of 8, h equals to 8 meter over here. So we are just putting the value of h equals to 8 here into x, just keep x as it is, into L value is 32 minus of x divided by 32 square. So if you just put this in your equation in your calculator, or you can manually solve it, so you will get this equation y equals to x in bracket 32 minus of x divided by 32. So we have the y equation as a 32x minus x square divided by 32, right? So this, what this y means, so this y is nothing but rise of arch at a distance x from the support A or B. So we have an equation of that rise of arch, okay, at a x distance from A support or B support. Okay, now whenever we are going to use we need to calculate the rise of an arch, we will use this equation. Okay, now let's move to the main calculation of the horizontal thrust. Now we need to calculate the horizontal thrust. How we'll do that one? So for that, first of all, we need to find the moment equation, which is the mx equation we always say. Okay. To calculate the mx equation, guys, we need to draw this beam diagram once again with this table, right? So they are the two span in the beam, which is A to B. Okay, let me just draw. One is the A to B or A to C, and another one is the C to B. Now we have the two span. So we'll be drawing the two sections in the two span, which is the x section at a x distance. So we have the x distance over here and x distance from B support, right? So there is a two x distance we have. Now what we are going to do is we are just going to prepare this table. So this table consists the portion, origin, limit, and the moment equation. Correct? So the portion for the first span is A to C. So we just written AC over here. Now we have a origin for this portion is A, and the limit is the length of this span is 16 meter. So it is 0 to 16. Similarly, let's write down the another portion, which is BC, B 0 to 16. Correct? Now see guys, we need to identify the moment equation for the AC portion. So how it look like? Now we have the value of VA over here, which is 600. So let's write down over here. VA is equals to 600 and VB equals to, it is 200. Okay, and these all are in kilo Newton. Understand? Now, so what we're going to do is, let's take a moment at this section, not A point. We are going to take the moment at the section where we have drawn. So it is 600 into x, right? The first equation we got 600 into x. So let's draw here 600 into x minus, now we have the uniformly distributed load and on that span. So 50 into x divided by 2. Why? Because 50 is the load, x is a distance, and we have converted this unit w like UDL in the point load. That's why this x divided by 2. Okay, so we got the x divided by 2 over here. So we need to solve this equation. So it will be like 600x minus 2 divided like 50 divided by 2 become 25, x into x square, so 25x square. So we got an equation 600 minus 25x square. Okay, now again let's do the moment equation. Let's calculate the moment equation for the BC. So to calculate that one, we can see that BC at this point, okay, we have the equation like uh, just a moment, just give me a moment. Okay, so it will be 200, this will be act as a, okay, 200, okay, into x. So this, let me just remove this one. Okay, so this will be act as a like this. Okay, so here the anti-clockwise rotation become the positive, so it will be 200 of x, right? That's it, because there is no more any load over there, so only 200 into x. Correct? So this is clear. Now we have two equations with us. The first equation is 600x minus 200 minus 25x square, and another one is at 200x. Now we need to do some calculations. That is movement equation into y, which the rise which we have calculated. So movement into y, that's we are going to calculate. So it's very easy, guys, right? So we need to do a integration of, okay, so this is an integration of 0 to 16, which is mentioning over here. Okay, so 0 to 16. Why 16? Because 16 is a limit that we have mentioned here. Okay, so 0 to 16 in bracket. First let's write down the movement equation, which is 600x minus 25x square into what is the value of y. We have calculated this is the value of y. Okay, so movement into y into dx. Don't forget to write down this dx, otherwise integration will not consider as an integration. Okay, this should be there. Plus, again, for the race span, integration of 0 to 16, 200x is the equation, mx equation, and the value of y into dx. Okay, so now you need to put the value of x as a 16 over here and use your calculator to just fill this equation as it is. So instead of x, you need to fill the higher value which is given, which is available here as a higher limit, 16. So you will get these figures. I request you to solve the first equation in the calculator and then solve the another one. Okay, if you're not aware on this, please drop me the message in the comment section. I'm gonna prepare a video on that one and help you to get these values, right? Okay, now we now got the, after addition of all this two figure, now we got the value of movement into y dx as a 436906.67. Okay, now there is another equation which is integration of y square into dx, so which is 8lh square divided by 15. So this formula, please remember this formula because this formula is very crucial. Okay, without this formula you cannot solve this numerical, right? So there is some shortcut, but this shortcut can only use in the examination like GATE and SSC. But in your regular college examinations, okay, university examinations, you can't use that one, okay, to solve the numerical. You can only use that one to check the numerical, okay, whether it is correct or not. So integration of y square into dx. So the formula is 8l h square divided by 15. So 8 as it is, L value is 32 over here, H value is 8 square divided by 15. So H is 8, just make the square of that one. So you got the integration of y square dx as a 1092.26. I hope this is clear to everyone. Now we have the formula for the horizontal thrust, which is H equals to integration of m into y into dx divided by integration of y square dx. This is the basic equation to calculate the horizontal thrust for the arch, right? So we already have the both the value for this equation. So this is a one value we have, okay, and this is the another value we have. Just put both value over here and we'll get the value of 400 kilonewton as a horizontal thrust. Okay, so this is a value of horizontal, okay, thrust. Understood? Now, so this is a value of horizontal thrust. Now, how you can check that this value is correct? So for that, you can check that when H equals to WL square upon 16H. So this is the very crucial formula which gives you the cross check function that yes, whatever you have calculated, that's correct. So let's put down some database just like that. W equals to 50, L equals to 32, just make the square of that one. 16 into H value is equals to 8, right? So you got the value 400 kilonewtons. So whatever you have calculated from the above procedures, that is perfect, that is correct, and and you solved your numerical very easily. Okay, so I hope guys this video help you a lot. In upcoming video I'm going to share you how to calculate the positive and negative maximum bending, maximum bending moment. Yes, right? So this is very important video for all of you. Okay, and after that I'm going to help you to calculate normal thrust, okay, and radial shear at ground and at certain distances. Okay, I hope this video help you for to solve your university numericals and some GATE and SSC JEE examinations numericals too. Okay, so have a nice day, guys. Bye bye.